Okay, question 8. The potential difference across a wire is 1.5 volts. The charge is 0.042 coulombs. Calculate the energy. So this is our vultures, whip, queens, but we know that work and energy are very, very similar. Opposite side of the same coin. So, but it tells us exactly what to do. We don't even need to rearrange that equation. E equals Q times V. So take your numbers because they're in coulombs and they're in volts. No unit changes. So that's quite pleasant. Next one, figure 20. This is a very common question, so make sure you're good at this. Add connecting wires, a voltmeter and ammeter to complete the circuit. So they're wanting to do an investigation on Ohm's law, and we know, well, the first job, let's get a voltmeter and put it around the wire and make sure it's connecting to those connectors. We're going to need to put an ammeter in the circuit. If you were to put 2 ammeters in, they'd still give you the mark. We only want 1, and I've picked the right-hand side. And then I've just got to make sure everything is all connected with no gaps. There we go. 2 marks. The students extend the investigation to determine how the resistance changes with length. Give name of 1 additional piece of apparatus. Well, they're going to need a ruler. So I'd actually then have a ruler in here. And then I'd attach my crocodile clips to make sure I've got a nice point of contact. Now, if you want to do it poshly, you'd use these things called jockey connectors or jockey wheels. So we're going to need a meter ruler, we're going to need some crocodile clips or a sliding contact jockey. If you don't know what that is, Google it and it'll show you a little picture of it. But it's just a posh way of attaching it so that you get a precise measurement. Next one, we've got a graph of the results. So we've got length in centimetres increasing along here and the resistance increasing in ohms. Draw a line of best fit. So there we go, through as many of the points as possible. We're trying to make sure that the total distance there adds up to those distances, and that's about right. So I'm pretty happy with that. 1 mark. And then it's estimate a resistance of 100. So we're just going to, read from 100 there, read across, and I can see that's bang on 3. So 3 ohms. Next part, the variable resistor is used to prevent the iron wire becoming too hot. So I've said to you, in terms of anything, it's get your cell or your battery or whatever it is you're wanting to do, get an ammeter in the circuit, put whatever it is you want to test in that gap, get yourself a variable resistor, put a voltmeter around the gap. And why are we doing this? Because this enables us to make sure that the wire doesn't get really hot. So explain how the variable resistor is used. Well, we can use it to increase, or in this case, decrease the voltage. So it increases the resistance in the circuit, which gives a smaller current to prevent heating. Okay, so with less voltage, we get less current. But the crucial part is it increases the resistance. I am able to turn a dial to increase the resistance so that I get a slower current moving around. Okay, next one, we've got the potential difference is 1.56 volts. The current is 0.5. So we've got voltage, current. It says calculate the resistance. So this is your I'm very rich. It says calculate the resistance. So divide both sides by I to get R on its own. And we're left with R equals, V over I. There we go. And we can directly just put those in. So 1.56 over 0.45 is 3.5 ohms. Common question that, please be good at this one. Please be good at this one.